Welcome to the Sense Making in a Changing World podcast, where we explore the kind of thinking we need to navigate a positive way forward. I'm your host, Morag Gamble, permaculture educator and global ambassador, filmmaker, eco-villager, food forester, mother, practivist, and all-round lover of thinking, communicating, and acting regeneratively. For a long time, it's been clear to me that to shift trajectory to a thriving one-planet way of life, we first need to shift our thinking. The way we perceive ourselves in relation to nature, self, and community is the core. So this is true now more than ever, and even the way change is changing. Unprecedented changes are happening all around us at a rapid pace. So how do we make sense of this? To know which way to turn, to know what action to focus on, so our efforts are worthwhile and nourishing and are working towards resilience, regeneration, and reconnection. What better way to make sense than to join together with others in open, generative conversation? In this podcast, I'll share conversations with my friends and colleagues, people who inspire and challenge me in their ways of thinking, connecting, and acting. These wonderful people are thinkers, doers, activists, scholars, writers, leaders, farmers, educators, people whose work informs permaculture and spark the imagination of what a post-COVID, climate-resilient, socially just future could look like. Their ideas and projects help us to make sense in this changing world, to compost and digest the ideas, and to nurture the fertile ground for new ideas, connections, and actions. Together, we'll open up conversations in the world of permaculture design, regenerative thinking, community action, earth repair, eco-literacy, and much more. I can't wait to share these conversations with you. Over the last 3 decades of personally making sense of the multiple crises we face, I always return to the practical and positive world of permaculture, with its ethics of earth care, people care, and fair share. I've seen firsthand how adaptable and responsive it can be in all contexts, from urban to rural, from refugee camps to suburbs. It helps people make sense of what's happening around them and to learn accessible design tools to shape their habitat positively and to contribute to cultural and ecological regeneration. This is why I've created the Permaculture Educators Program, to help thousands of people to become permaculture teachers everywhere through an interactive online dual certificate of permaculture design and teaching. We sponsor global perma-youth programs, women's self-help groups in the Global South, and teens in refugee camps. So anyway, this podcast is sponsored by the Permaculture Education Institute and our Permaculture Educators Program. If you'd like to find more about permaculture, I've created a 4-part permaculture video series to explain what permaculture is and also how you can make it your livelihood as well as your way of life. We'd love to invite you to join our wonderfully inspiring, friendly and supportive global learning community. So I welcome you to share each of these conversations, and I'd also like to suggest you create a local conversation circle to explore the ideas shared in each show and discuss together how this makes sense in your local community and environment. I'd like to acknowledge the traditional custodians of the land on which I meet and speak with you today, the Gubbi Gubbi people, and pay my respects to their elders past, present and emerging. On the show today, I'm delighted to welcome my friend and member of the Permaculture Education Institute, Dr. Brian Von Hurzen, who's the founder of the Climate Foundation and creator of Marine Permaculture. You might have seen him on the 2040 movie talking about marine permaculture, or seen marine permaculture written up in Drawdown, the book by Paul Hawken. In this conversation, Brian explains a little bit more about what marine permaculture is, how it works, what are the benefits that it can bring, and how it connects in a really integrated way with terrestrial permaculture. This is a fascinating conversation on the edges of the new dimensions of permaculture and stretching the boundaries of where permaculture can go. I hope you enjoy this conversation as much as I do every time I get the chance to speak with Brian. Well, thank you so much for joining me, Brian. It's so great to have you back on the show. Well, actually, the last time we met online like this was in a masterclass, and so it's great to have you on the podcast today. So for the listeners who are here today with us, this is Dr. Brian Von Hurzen. You may well know of him as the person who's brought marine permaculture to the world. You might have seen it in the 2040 movie or in the Drawdown book, or heard one of his talks at Woodford Folk Festival. Brian's also a member of the Permaculture Education Institute community, and he's actually my almost neighbour now, living just down the road near the Woodford Festival. So it's wonderful to have you here today. Thanks so much for being here. And what I really wanted to start, before you dive into telling us more about what is permaculture, is more around why the permaculture. I mean, I'm so excited that you brought marine permaculture into the world, because it's completely expanded, I think, the permaculture community's sense of what permaculture is. Up until this point, our definition of permaculture design has kind of ended at the coastal areas, and what's out in the ocean was sort of zone 5 wilderness. But now you're expanding our thinking into how we can explore that too. But why? What is it that brought you to create marine permaculture? What's going on in the world that you feel that we need this solution?
Well, thank you, Morag, and it's great to be back, and it's great to see you. I think for one thing, for me, the ocean's always been zone 1, because my father was an oceanographer and I was growing up next to the sea. And so getting into the water is just this huge part of my life. But beyond that, I've had someone tell me recently that ocean is the climate, that if you look at the actual volume of biosphere that's available on the planet, that something over 90% of it is in the ocean. And so in terms of the biosphere, the space for creatures to live, the ocean is vast, it's enormous. And then furthermore, if you consider how the ocean, I mean, we've just lived through 10 days of rain here in Southeast Queensland, and this is all caused by an ocean storm that's just swirling in the moisture. So it's like, can't wait till Wednesday comes along and the rain finally stops. But I feel a little bit as though it's Winnie the Pooh and Christopher and the umbrella. We're sort of waiting for how many weeks of rain are we going to have. And that's just a great example of how the ocean, and La Nina in this case, has such a profound effect on our terrestrial biosphere, both in terms of the rainfall, and we've lived through flood years and we've lived through drought years. But the reality is that in a warming world, the jet stream slows down, it varies more and more. And as it varies more and more, we're going to have drier dries and wetter wets. We're going to have higher highs and lower lows in temperature. And that means that we have to prepare for those challenges on land, and fundamentally try to address how to adapt and how to ultimately mitigate the climate changes that we're causing in the sea as well.
Mm-hmm. So marine permaculture then is a way to help us adapt to this changing climate, at the same time as helping to draw down carbon and help to regenerate life, regenerate damage that's been done. So can you maybe describe a little bit about how marine permaculture works in doing both those sides of things?
Yes, I think a great example is off the eastern shores of Tasmania, where sadly 95% of the kelp forest is gone, and people didn't know why. But in most of the ocean, the surface layers of the ocean have warmed 1.1 degrees Celsius already, and that's due to the global warming of the previous decades. In my hometown of Woods Hole, Massachusetts, the average temperatures increased more than 2 degrees Celsius, and that's because it's in a particular hotspot. But if you go to the eastern shores of Tasmania, the East Australian currents become stronger and stronger, and has brought a lot of warm energy down to the eastern shores of Tasmania. And the result is 3 to 4 degrees Celsius of warming. And the temperature by itself is a bit of a problem, but the temperature creates a warm layer of water that presents a barrier to restoring natural upwelling. It's a barrier to natural upwelling. When you have a normal amount of wind and a normal amount of wind shear, the plants in the ocean still rely upon nitrate and phosphate and micronutrients, but the supply of those macro and micronutrients are several hundred meters below the surface, and the water is cooler and much higher nutrient levels. So to restore natural upwelling, that's what we need to do, and the thermal barrier is that much greater. And of course, these macroalgae, these seaweeds, these giant kelps, are some of the fastest growing organisms on the planet. And they can get up to 60 meters long, and they can grow half a meter per day. But they need lots and lots of nitrate to do that. And when there's plenty of upwelling, that's fine. But if it's warmer temperatures, it's like putting a lid. It's like shutting down your air conditioning system right when it's getting warmer. It's a bit of a problem.
So can you tell me a little bit more about what's happening to the kelp forests around the planet? I mean, that's what's happening on the eastern seaboard of Australia. What's happening everywhere?
Off my home state of California, they've lost 95% of the Nearest kelp forest north of San Francisco. So Northern California has lost 95% of its forest. It's turned into mostly urchin barrens. And until those Kina barrens, as they call them in New Zealand, are addressed, it's not coming back. It's like Easter Island. You can have a forest or you can have a savanna. But once you cut down all the trees, it's only a savanna, and it's going to take a large amount of energy and effort to get it back over the hill and back into some kind of a forest. Similarly, when you jump over the hill and get to the Kina barrens, you get to the sea urchin barrens. You have to address 99% of the sea urchins and the environmental conditions to get them back, and that's where marine permaculture comes in, because we can restore natural upwelling, provide a substrate off the seafloor, and enable the kelps to grow, even if you're dealing with a Kina barren situation. That problem exists in New Zealand, in Australia, in California, and around the world. We're seeing, even in the Philippines, 250,000 seaweed farmers depend upon that seaweed production for their communities. And they're living on the front lines of climate disruption. And what we're doing right now in the Philippines is we're able to enable those communities to adapt to the warmer temperatures, provide enough irrigation. That's kind of like irrigating farmland with drip irrigation. With enough irrigation, these seaweeds thrive. We're actually getting 4 to 6% growth per day out of these seaweeds that are irrigated, compared to +1 to -4% during the same time period without irrigation, with just surface water irrigation.
So tell us what irrigation means for a seaweed farm, because that's kind of a different concept.
It is. We're irrigating with cool, deep water, and that deep water has the higher nutrient levels. And so literally, we're irrigating seaweed farms. In fact, solar irrigation for seaweed farms is a thing. And it's really about bringing up the deep water and enabling that deeper, cooler water with the higher nutrient levels to go past the seaweeds. The seaweeds can concentrate the nutrients by 10,000 to 1 and absorb the nitrate and the phosphate and the micronutrients and grow beautifully. And so we're actually able to rescue the growth of those red seaweeds in the tropics. And we're also able to rescue the production of kelps. As we've tested in Tasmania, near one of the fish pens as a proxy for higher nutrients, we were able to restore the growth of these seaweeds we had just 2.5 meters per day in a control region, and in the higher nutrient zone, 2.5 meters in a year growth in 12 months. And in the same time period, we got 10 meters of growth next to the fish pen. So it really suggests that multi-trophic permaculture is the answer, because it addresses nutrient uptake, and it also it rescues the production of giant kelp.
Mm-hmm. So tell me a little bit what you've noticed once these kelp forests start to grow. What's going on in amongst that as well? Are you seeing, a coming back of diversity of other life as well into these areas?
Yes, what we saw, it was amazing. Just in the first few weeks in the tropics, we saw squid eggs. The squid come up at night and they lay their eggs in the sea forest. And so you can find little squid eggs everywhere. And they're juvenile fish that are younger than the deployment of the marine permaculture platform. So they were actually born there, or just, there are thousands of them. It's amazing. And furthermore, within a matter of weeks, we had thousands of sardines, hundreds of tuna fish, a family of dolphins that spent more than a month circling our area, and a whale shark swam an estimated 200 kilometers to come over and eat some of the algae. So nature has voted with her fins. Mm-hmm. And she said, you got the good stuff at marine permaculture, and everybody's coming over. The sardine fishermen fish there day and night and around the outsides. And of course, the forest remains a incubator, if you will, a hatchery, if you will, for some of the small forage fish. And those forage fish eat algae, and they are protected. Their habitat is algae as well. And so really the adoption by these natural fishes and invertebrates is really inspiring. It's something that, we find time and again, if we give nature half a chance, she'll rebound with abundance, the cornucopia of abundance.
It's amazing. So from a perspective then too of carbon and how much drawdown can marine permaculture think to have? Because you're saying there's so much growth in the seaweeds, and yet we're trying to do lots of tree planting on land, which we need to do. But how can the seaweed forest regeneration, or another term that you're using now, how can that help to draw down carbon at rates that are needed in the world today?
Well, we all know that the Amazon rainforest can draw down vast amounts of carbon, an estimated 2,200 grams of carbon per square meter per year. What is less known is that the seaweed forest can actually draw down 15% more carbon per square meter per year than the tropical rainforest on land. Now, some of that carbon will typically go back to the atmosphere, but if we grow the sea forest, sustainably harvest for food, feed, and fertilizer and other products, and have the residual seaweed sink into the middle and deep ocean, if it gets down 300 meters, it's safely sequestered for over 100 years. And if it gets down 1,000 meters, which we can measure, it's good for about 1,000 years. And that means that we have a very long-term sequestration. And the ocean today is holding 45 times as much carbon dioxide as the entire atmosphere. So there's truly plenty of room to enable the biological pump to sink that carbon and have it go into the middle and deep ocean from whence it came, actually. So it's a huge opportunity. And I think I'd like to say, people may come for the carbon, but stay for the regeneration, because ultimately it's the life on the planet that's going to be regenerating in the seas, and the soils are abundant.
What really excites me about marine permaculture, I think, is the potential when you start to talk about the food that we can grow in these kelp forests. The food for people, food for the soils, and also food for the land-based animals that we care for as well. So can you just talk a little bit about those kinds of foods and what the potential that has for us?
Well, let's start with the animals. We've learned that this local seaweed right here in Queensland, Asparagopsis, is amazingly good at reducing the enteric methane emissions of ruminant livestock. And it turns out as small as a 1% feed supplement is able to cut about 90% of the methane of the ruminant livestock. So cattle, sheep, goats are all on the table. In fact, I'm not sure, but I was reading recently that maybe kangaroos are also ruminants. And if they are, then they could use a little seaweed as well. What I love is the fact that in New Zealand, the deer at night go down to the beach and eat seaweed naturally, all by themselves. And we know this because the hunters go down there and shoot them. Wow. But the fact that the ruminants choose to eat seaweed, and probably in a 1 to 10% ratio is what I'm guessing, for many types of seaweeds. Now, people have focused quite a bit on Asparagopsis, but there are actually other seaweeds that can be very healthy for animals as well, and healthy for humans. There's 14,000 species of seaweed, and I think we've tried just a couple dozen. So when I go surfing, I usually try out some different seaweeds because they're nearly all edible and, not bad for you if the water's clean. There's no problem whatsoever. The other thing I want to touch on is that food for the soil is so important, and food for our bodies is so important. And I'd like to touch on, well, to me, it's very poignant that Petri dishes are where we grow microbes. Those Petri dishes are made out of agar, and agar is made out of seaweed. And so it's not an accident that all these things are happening. And it turns out there's some amazing prebiotic aspects to seaweeds that are profound for both flora and fauna. First, with ourselves, if we put seaweed into the soils, those prebiotic effects really help the soil microbial communities, and that really facilitates the generation of a living soil. And it turns out our own guts are not that different from the soil. Sometimes babies eat dirt, and it may not be an accident from a pure reason for it. But So when we eat little bits of seaweed, that prebiotic actually can have a fairly profound effect on the gut flora that occur in the intestine because unlike some of the probiotics, these prebiotics get right through the stomach. They are able to get to the intestine, and they can actually influence the balance of the gut flora that give us a healthy immune system, a healthy digestive system, really. And so to me, that's very profound. And we've seen some amazing health benefits associated with reduced cancer rates in Asian women, reduced metabolic syndrome, which reduces obesity, and on some cognitive health span benefits as well. So, and from a health standpoint, on the human side, it's really profound. In the soils, it's great. And one of my favorites are the biostimulants. And that is, if you add just, there are these seaweed foliar biostimulants that if you spray on the leaves of plants in the morning, like before the stomata have closed, these plant growth regulators that are present in the natural seaweeds go into the stomata and upregulate the gene expression of the plants. And it means that with less application of fertilizer, you can actually get higher yields, which is very counterintuitive. But effectively, compared to a plant that has all the NPK fertilizer it could use, when you add these seaweed foliar biostimulants, you get double-digit yield increases on every flowering plant, just about. I mean, we've seen it for vegetables, we've seen it with fruit trees, we've seen it with grapes, and we've seen it even with row crops. So imagine, and I think there's a variety of these that are available, but we're developing some now and looking forward to really enabling that to come forward. And so whether it's plants, food for plants or for microbes or for people or our animals, it turns out the seaweed is really profoundly wonderful. So we're looking forward to working with volunteers and partners all around the world to really explore what can we do with seaweeds, because there's so many to choose from, and that we've just explored the tip of the iceberg so far.
So how many edible seaweeds are there, do you know?
Well, nearly all of them are non-toxic. So there are 14,000 species of seaweeds. They're reds and greens and browns. The kelps are all brown seaweeds, but some brown seaweeds are not kelps, for example, sargassum. And, the Japanese eat sargassum even as well. And I think I fed some to Damon Gameau when we did our film. So it's really fun. And, it's a great texture. And then people love pasta, but, pasta is all about the pasta sauce. So I kind of view seaweed as the wonderful, healthy pasta that goes underneath the pasta sauce.
So is there anything that people need? Sorry, I'm just taking a bit of a sideline here. If people walking along the foreshore and they see some seaweed and they're wanting to eat it, what do they need to know?
Well, if it's really healthy and it hasn't decayed, and it's beach cast, people do collect beach cast in Australia. They bring it home, they dry it, and they use it. For example, there are several examples of using the common Eclonia kelp. And so if it's healthy and just washing on the beach, it's fine. When I'm not surfing, I'll actually pick a seaweed that is actually attached to the rocks at the bottom. I'll just take a leaf or two, and it's fun to chew on when you're surfing. And, that's really great. And so I know that it's something that it's good to have healthy living seaweeds. And I think when it comes to cultivation as well, it's really good to be able to harvest and get that sustainable cultivation. Most seaweed is done dried today, but I'm very happy to say there's some products like seaweed sauerkraut that have a little percent of seaweed in addition to the cabbage. Mm-hmm. And I found some down in Byron Bay. And I think those are a great example of some of just the tip of the iceberg of the kind of foods we can produce with non-dried seaweed that retains all of the antioxidants, phytonutrients, and omega-3 fatty acids that are present in whole seaweed.
So how do people grow this then, because marine permaculture is at a scale that's different from a backyard permaculture. So how do you get into a marine permaculture? What does that look like in a practical sense?
Well, right now we're doing a very small system, and we've validated the biological response, which has been great. The seaweed's been growing 2 to 4 times more than the non-irrigated forms of seaweed. We need to do a stepping stone of around 1,000 square meters that will enable us to show the scaling and show that it works. And then we're aiming for a family-sized business, which will be on the order of a hectare, or a fraction of a hectare. And that would be offshore where relatively deep water is available, or if the shoreline is fairly steep. where we've got access to deeper water, and we can use wave energy, wind energy, and solar to effectively provide the deep water irrigation to the seaweeds and enable it to grow 3 or 4 seasons a year. And so we're envisioning, and we have families from New South Wales to Western Australia who are saying, we'd love to be doing a hectare of marine permaculture. It's a family-sized farm, and every seaweed farmer in the Philippines is permitted to have a hectare of seaweed growing there. So there are already 250,000 seaweed farmers in the Philippines, and that's one reason that we're starting there, because they've been growing seaweed for decades. Their families do it, everyone does it. And the problem is the water's too warm, the nutrient levels are too low. So we have to bring the irrigation services in and enable these farmers to regenerate their farms, because we see hundreds of hectares that are today are absolutely empty because the water's too warm and it won't grow the seaweed. But when we bring in these, the deep water irrigation and some improved farming techniques that improve sustainability and get rid of the use of plastics, enable these farms to come back. And so we're getting a lot of help from the local governments and mayors to really bring this back, because it's the subsistence living of these seaweed communities. Once we get that right in the Philippines, and we have the hectare farm working well, and some examples here in Australia as well, I'm looking forward to, there are that need this technology. And so it really is essential for these large groups. And of course, the geography and bathymetry of Indonesia is perfect because it has steep shorelines, it gets deep racing. And so that means it's very easy to do this. And so that's the hectare size system that we think will work well. Then it may be along the way that we find some smaller systems that can be possible as we go on. So that should be possible. And then further offshore, if you go off 100 kilometers or something, we should be able to do larger systems as well. So I'm thinking there's a family-sized business to be done, especially for those who really live with the sea. We've got friends and colleagues. They're swimming in the ocean and they're diving and they're doing all these, really engaging. It becomes zone 1 and zone 2. That's just, and so that's probably where we'll start, with the people that are just living and breathing all the time in this environment. And then there'll be some fishing alongside the marine permaculture as well.
And I remember you talking a while ago too about your interest in Azolla. Can you talk a bit about that? So bringing your watery world awareness into the terrestrial landscape.
It's incredible. Azolla, it's amazing. We got our inspiration from 49 million years ago, an event called the Azolla event, in which Azolla grew out over the Arctic Sea at a time when it was very warm up there. And every spring, it would grow and spread across 1 million square kilometers of the Arctic Ocean, and it would just bloom and grow because there was a freshwater lens right on the top of the Arctic Sea. And then it would grow through the summer. In the autumn, it would start to die because it was losing sunlight. And then it would sink into the anoxic Arctic Ocean and put down a layer of oil. And it turns out, the geologists say that most of the oil in the Arctic comes from Azolla, which is just amazing. And here it is, a native plant of Queensland. And when it comes to freshwater permaculture, Azolla is amazing because it fixes nitrogen. It's one of the few freshwater plants that actually produce EPA and DHA, which for a third of the population, they can't produce it well themselves. They need to ingest it. And if you're a vegetarian, your only sources are going to be Azolla or seaweed. And so that's really key. And then, sardines or something, small fish will also accumulate it. And so it's an opportunity in a freshwater environment to actively draw down the nitrogen because it fixes nitrogen. Even if the freshwater environment goes to 0 levels of nitrogen, very low levels of nitrogen, if there's phosphorus there, the Azolla will assimilate the phosphorus and fix the nitrogen a bit more slowly. And so it's interesting because Azolla grows next to duckweed. Azolla is an aquatic fern, very old ferns, and duckweed is an angiosperm, so it actually flowers. And so they're living together, and the duckweed cannot fix nitrogen. So it grows quickly, it'll double in 2 days. And it grows quickly until it's out of nitrogen, then it's gone. Now the Azolla will come in and it will go a little more slowly, but it will assimilate all that extra phosphorus and process that. And what I love is how the fish love to eat Azolla. The chickens love to eat it. We've fed it to horses and cows. And guess what? If you feed it to chickens, they'll produce omega-3 eggs. And if you feed it to cows, they'll produce omega-3 milk. So it's actually a wonderful circle of a circular natural value chain, I would say, from water and aquatic environments to the land and back to the water again.
Mm-hmm. And I've been known to have a bit of a nibble myself as well.
Oh, yes. I've got friends who put it on their salads.
Yeah.
Just with sprouts.
Yeah. I mean, particularly if you know where it's grown, if you've got a little bathtub that's got it growing in, I use it to grow mulches for the garden or to add into the compost and do things like that as well. So it's, and it's nice and fresh. You just have a nibble, and it's so abundant. And that's right.
That is just the way I feel about the seaweeds when I go surfing.
Yeah, right. I know, it's so great, like this whole concept of forage gardening, that we can be creating systems that are so abundant that we can just be surrounded by these kind of food systems where we go. So I think it's amazing. I'm so excited to have this sense of permaculture broadening out across the globe and into a scale that you're thinking of that is really addressing the key challenges that we're facing.
I have to share with you. Yes, I have to share with you something that Dave Holmgren told me. And he said that Bill Mollison's original inspiration for permaculture was in the Tasmanian kelp forest of eastern Tasmania, that he saw the relationship between the kelp and the fish and the seabirds and the marine mammals. And that was his inspiration. And then he applied it to the rainforest of Tasmania and the marsupials and all the rest. And the fact that we're going full circle and now we're bringing marine permaculture back to the marine environment, to me is so inspiring. It's kind of a circular inspiration in addition to the circular value chains where we're enabling the seaweed to regenerate the land. And of course, the land will have this beneficial effect back in the ocean. Yeah, so I see that as really important.
What are some of the other conversations you've been having? Because I know you've been talking a lot with David Holmgren lately, particularly in writing about marine permaculture in relation to the ethics and the principles. What other kind of conversations are you having that are really diving deeply into the permaculture world and making the connections?
Yes, we've been working with Dave Holmgren and Scott Spilius on really applying the dozen design principles of permaculture to the marine environment. And I really love that because that's where these design philosophies and principles can be applied to a completely new ecosystem. And it turns out it's so applicable. I like to say life loves a gradient. And that's one of the principles that I was reviewing today. And, the ocean is full of gradients. You've got the land and the sea interface. You have the beach and that's the intertidal zone where it's sometimes covered and sometimes bare, to the subtidal zone, which is always in water, but it has inputs from the land. So these, life will choose where to live in that gradient. And if you give it a nice gradient, you'll see where particular species end up. And so that is a natural succession that is wonderful. And the ocean, especially along the shoreline, is full of gradients. And I think that's just one of the 12 design principles that we hope to, really articulate later this year in an article that we hope to publish together.
Fantastic. That's wonderful. So what do you think are some of the key ways that marine permaculture can, my question really is around what are some of the things that you think are some of the challenges that you're going to face in rippling out this amazing concept, and how some of the ideas already that you've seen to get it unstuck, I suppose, because it's a big vision that you're holding here. It's huge.
That's so true. And we're working right now. It's been wonderful to have the crowdfunding, the philanthropic crowdfunding that's enabled us to get this far. And we're fundraising now to get to a 400 square meter platform in the Pacific that will enable us to demonstrate this scaling. And very happy that we were able to complete the funding for the first 200 square meters just last December. So it's really a matter of capital raising initially, because the first systems are more difficult. They're, it's like permaculture for the first time. If you don't know the right combination of organisms, sometimes it takes 2 to 5 years to really get a permaculture working nicely. And so then it becomes easier and easier. And we see the same thing in the marine environment, in the marine context. So we'll get better at doing this and building larger systems. And once we've demonstrated that it works, I think demonstrating that the hectare scale is actually economically sustainable. And the first products are food for people, food for our livestock, and biostimulants for agriculture. And I think being able to engage with those markets and really find value chains that work well is a key opportunity. And we're looking forward to doing that. And then effectively with a marine permaculture alliance, if you will, of farmers all over the world who are working to actually enable this to go, I think it really is the family-sized hectare scale farm, hectare scale marine permaculture that will enable this to begin to take off. And I think we want to demonstrate the economic model and be able to show that private investment can come in and have a sustainable return. And once that's engaged, then we can also look at, well, maybe 1 to 10% of the marine permaculture can be dedicated to carbon sequestration as well. And so I think there's going to be a balance, and there's many groups that are actually studying the natural carbon, the bits of kelp and seaweed that come off of the marine permaculture and off of the natural seaweed forest. Some of it ends up going into the deep in any case. And so that's a bit of a balance, just as the leaves will fall from a forest and end up on the forest floor. So we'll have certain seaweeds falling from the sea forest and reaching the seafloor. And when it reaches the seafloor, it gets remineralized and processed, and that carbon will remain out of circulation for centuries to millennia. So it is very parallel to a terrestrial forest.
Mm. Wow, fantastic. So how can people learn more about marine permaculture? Like if they're wanting to maybe become one of these future marine permaculture home, farmers, family farmers, or if they'd like to learn more about what it's about, where can they find out more information, Brian? Have you got materials that they can access?
Yes, we have a quarterly newsletter at our website, climatefoundation.org. We're doing a bit of a crowdfunder there as well, and we're engaging volunteers to actually scale the capacity building. Initially, it's more on the development side and research and development, but I'm expecting over the next year or two to transition to where we've got demonstration sea forests that can actually be harvestable sustainably. And I think reaching that hectare scale level of sustainable scale, and of course there's plenty of room in the ocean, that won't be a limitation. That will enable us to reach, I would say, the first plateau, and that plateau will be this economic sustainability that will enable more private investment to come in and the ability to actually obtain a yield. And that yield is going to be another one of the permaculture design principles, to obtain a yield that'll be sustainable. And
I was just thinking about the yield and the harvesting side of things.
Yes.
Sorry, we were starting to wrap up and talk about where to find more information, but I had the question and I wanted to ask you. So when you're harvesting the seaweed, how do you do that in a way that makes sure that there's still, like what we're doing in a permaculture garden system, you don't just kind of go and clear out your whole food forest and then you've got to start from scratch. Like there's a sort of an ecosystem that's happening. Do you do kind of selective harvesting as well within it? Like what's the strategy for maintaining the ecological integrity at the same time as harvesting it from there?
Yes. Well, a great example is Eclonia, which is the common kelp, which grows from southeast Queensland all the way around the Great Southern Reef to Western Australia. And that common kelp can grow 1 to 2 meters tall, and it can be partially harvested. In the case of the larger Microcystis, it'll grow 20 meters tall, and then it grows out along the surface. And by harvesting just the first top meter, it's like mowing the lawn. You mow the lawn, and the rest of the 20 meters is available for fish and to grow back quickly. So it turns out every 3 months or so, it's possible to do a Microcystis harvest. We're expecting typically for brown kelps, every 90 days, there could be a harvest. And for the red seaweeds in the tropics, every 45 days. And so that's 4 to 8 harvests per year. And we do partial harvests. In the case of the red seaweeds, a third of the harvest goes back to form the beginnings, the seedlings for the next crop, and it grows vegetatively. And so,
I'm really curious now. How do you propagate seaweeds? Like, how do you get seedlings and cuttings? Is it from cuttings, or is it from? I've never even thought about it before.
Multiple ways. One is in the red seaweeds, they grow vegetatively. And so there are many ways that they reproduce. And one of them is just split them in two. The injury to the plant actually causes it to grow faster until it gets up to its normal size again. So just like rotational grazing, the livestock injure the grass, but you only want them on the grass 1 or 2 days, move them to another plot away. The grass has 30 days to recover and grows back with abundance and increases its root mass in the soil. And so those perennials do beautifully with rotational grazing. This is like rotational grazing, where we're the grazers and we graze every 45 to 90 days. And when you do break the seaweeds, they come back faster. They respond to the injury and grow back faster. And that's one of the key parts to enabling that to work. And then there are hatcheries for kelps where you can actually harvest the sporophytes. They land as gametophytes and they settle. And then they have to make microsporophytes, and then they will grow. And it turns out the microsporophytes turn into macrosporophytes, and that's the giant kelps that we see. And so it ends up being a biphasic or a triphasic life cycle. And there are hatcheries. In fact, we helped to sponsor one at the University of Tasmania, and there are other hatcheries around the world that focused on brown kelps or some red seaweeds. And so there's both vegetative propagation and sexual propagation that occurs at different parts of the cycle. And sometimes you can go through 20 generations vegetatively and then get a new crop.
So there's a kind of an enterprise as well, nurseries for seaweeds. I wonder whether that's also something. But
I think it is.
My final question, I guess, to talking about propagation, I'm really getting into kind of the plant garden side of this. So what are there any pests or issues, that you have to think? What would come in and, are there sort of things like there's animals or, insects in the garden, like there's deer that come in randomly into my garden, or, grasshoppers. What are the sea deer or sea grasshoppers that could impact what you're doing there?
Well, in the tropics, we see these fish called rabbitfish that come in and they love to eat seaweed. But I think the trick is to have so much more seaweed than rabbitfish that, it ends up balancing out. And if that goes far enough, we do actually get, the tuna fish will come in and go after the rabbitfish, and other kind of game fish will effectively manage the populations. Mm-hmm. But just as with the regular permaculture, you need to have the right balance of the different trophic levels to enable that to be in equilibrium. And sometimes it can take a year or two to actually reach that equilibrium. So that's one example. Another example are what are called epiphytes, which just mean that something is growing on the seaweed, because anything that's a substrate is, a place for something to grow. So there are a lot of invertebrates that will actually grow on the seaweed. Now, kelps are slimy for a reason. And it turns out the slimy part of some kelps, like Microcystis, is specifically a biofilm to present a liquid surface so that epiphytes have a hard time attaching. Oh. And so it's a great way to, keep your boat clean, or in this case, keep the seaweed clean. And effectively, it helps to reduce the amount of epiphytes significantly. And then I think there are some permaculture techniques to manage the number of epiphytes over time as well. Oftentimes a spring harvest will not have so many epiphytes, but a summertime harvest may have more. So it's a combination of nutrients and temperature, and a matter of managing those effectively. And with the right kind of partial harvesting, it may be possible to manage those as well. So the species diversity is enormous, and our opportunity is to discover the right combinations to create a permaculture in that marine environment. that can live in equilibrium with a certain number of epiphytes, a certain number of rabbit fishes, and of course, game fish and apex predators in beautiful abundance.
Fantastic. And then I guess too from that, things, the biofilms and the bioplastics and all the other sorts of things that can be evolved and emerge out of this world as well. I mean, the innovation potential from exploring this is it's untapped, really, isn't it? I mean, it's
amazing. We call it the 7 F's: food, feed, and fertilizer, fish, biofuels, and fiber, and even pharmaceuticals. So there's 7 F's to begin with. The funny F at the end. But we've identified more than a dozen value chains in our economy today that can really enable the vision, the blueprint for seaweed in Australia to have a more than $1 billion industry sometime in the next decade. And that's only 5% of the global market for seaweeds today. So as we find more uses, those markets will get bigger, of course. And I think it's wonderful and commendable that here in Australia, we're aiming towards building a real viable seaweed production and seaweed harvesting. I think it's just a wonderful chance to regenerate life in the ocean at the same time that we're obtaining a sustainable yield.
Well, thank you so much for joining me today, Brian. It's always fascinating talking with you about this, and I get really excited about the potential for this and also about the possibilities for the interactions, this greater level of the feedback loops that we can get happening by really expanding our consciousness of permaculture beyond the landmass into the whole earth concept. And,
yes, I would say the positive feedback loops can really help to regenerate life in the seas and the soils. And by doing both of those together, we can bring nature along and be the change that the planet needs on a planetary timescale. Mm-hmm. So thank you, Morag. It's such a pleasure to see you again and to have the chance to talk with you about these important areas.
Thank you. And for everyone who's listening, I'll put all of the links to Brian's work down in the show notes, and you can follow the links there to access his resources. So thank you again, and take care, everyone. And thank you, Brian. I'll see you at the Australasian Permaculture Conference in just a few days.
Thank you, Morag. Looking forward to it. Take care.
Take care. So that's all for today. Thanks so much for joining us. Head on over to my YouTube channel, the link's below, and then you'll be able to watch this conversation, but also make sure that you subscribe, because that way you'll be notified of all new films that come out, and also you'll get notified of all the new interviews and conversations that come out. So thanks again for joining us. Have a great week, and I'll see you next time.